Professor Eric Mazu from the Department of Physics, Harvard University. Professor Mazu is a world-renowned scientist, pioneering research in femtosecond laser, and also a forefront science educator and the recipient of the famous Minerva Prize for advancement in higher education for his peer instruction. In 1990, he began developing peer instruction as a method for teaching large lecture classes interactively. He's also the author of Peer Instruction, a User's Manual, which was published in 1997. The book was highly successful and has been adopted worldwide. Professor Mazu is the author and co-author of over 300 publications, 36 patents, and several books, including The Principles and Practice of Physics, which was published by Pearson in 2014. There, he presented a groundbreaking new approach to teaching introductory calculus-based physics. Today, it is our honor to have him here with us to give a talk on the title of Educating the Innovators of the 21st Century. Please give our warmest welcome to Professor Mazu.
Thank you so much for that kind introduction. And it's a great pleasure for me to be here on your campus. I've been in Thailand quite a few times. I think I've been to Thailand 6 times. But this is my first time on the Chulalongkorn campus. So it's a great pleasure for me to be here, even though it's hot. So I would like to talk to you a little bit about the subject that's on the screen there, how to educate people who are creative, who are innovative, which I think is especially interesting, especially important, I should say, in the 21st century. So before we do that, let's talk a little about innovation. What is innovation exactly? And in order to illustrate what I think is innovation in science, I thought I'd give you a little story. And the little story I'm going to give you is about this man here, André Geim. He won the Nobel Prize in physics in 2010. I don't know if you know for what he got the Nobel Prize. He got the Nobel Prize for graphene. Graphene is a single layer of carbon atoms. Graphite is many layers of graphene. And the way he discovered graphene was basically by taking a pencil was what you write, for science that makes you laugh at first and think afterwards. These are all kinds of papers that are published in peer-reviewed science, but if you read the title, you'll start laughing. Let's see if I can find an example for you. I think one example is from a paper published in 2010. I have to look it up because I forget the title. It's so crazy. Where is it? I need to look it up. Dizziness in discus thrower. Dizziness, right? To be dizzy. In discus throwers, the people who throw a disc at the Olympics, is caused by spinning while throwing the disc. Believe it or not, there was a paper that actually appeared in a scientific journal. Well, they invite the people who win the Ig Nobel Prize to Harvard. The people don't know what the prize is. They put them in front of 1,000 students from my campus, and they give the person 2 minutes to explain their paper. And during those 2 minutes, the students throw paper airplanes at these people who win the prize. It's for fun. Well, he won the Ig Nobel Prize for levitating a frog. He actually took a frog and levitated it in a magnetic field and published a paper about it. So in 2000, he won the Ig Nobel Prize, which was a joke. In 2010, he won the Nobel Prize, which is the biggest honor you can get in science. Now, if you go to the Nobel website and you read his interview, there's actually something really interesting. Because he describes in his interview for the Nobel Prize that it's very boring for him to work on the same thing over and over and over again. And in order not to get bored, what he does is he pushes his student and himself to do these Friday night experiments. Oh, why does my computer turn off? Let me turn it back on. I'm sorry about that. He describes that both levitating a frog and graphene was the result of what he calls Friday night experiments. On Friday night, he pushes his students to look at equipment that's lying around in the lab and to try to do something new, something you could do too, in your labs or in your kitchen or wherever. One day, it won him the Ig Nobel Prize. 10 years later, he won the Nobel Prize, and now he is a famous physicist. So, the question I'd like to address today is how can you foster this creativity, this innovation? How can you make people to be more like Andre Geim and to try to do things that are different, that will advance the field or society a lot? Well, the answer to that question, which we're going to talk about in the next hour, is that we need to push people to become real problem solvers. I'm sure that in your courses, one of the things you do is you try to teach your students problem solving. But I will argue that a lot of problems that we teach our students to solve are not really problems. They're at best exercises. The other thing is that we need to encourage our students to take risk. It's okay to make mistakes. It's okay to fail. If you do not fail, you have not tried hard enough. The road to innovation is littered with failures. Think of any big invention, like the light bulb invented by Thomas Edison over 100 years ago. Before he had a working light bulb, he had 300 failed prototypes. He failed 300 times. Most people would have said, "You're crazy." But he said, "No, I'm going to continue." He was okay with failures. And if he had not continued to fail, we would probably be sitting in the dark here. So encouraging risk-taking is really important. Okay, you all have this little clicker, right? Everybody should have one. Do you have one? Yeah, good. Okay. I'm going to explain to you how the clicker works. It's not very complicated. Oh, that's me. It has no on-off button. It's always on. I'm going to ask you questions later on. And when you're ready to answer, you press a button. So if you press a button, you will see, if you press 5, for example, you will see 5 in the little window. That means that, oh, look at that, we have a visitor. As long as he stays there, it's okay. So I'm going to ask you a question, and if you answer and then you change your mind, this is not a problem. If you, let's say you press 4, and then you think, oh no, I should have pressed 5. Just press 5. That doesn't mean you get to vote twice. The 5 will erase the 4. So it's only the last click that counts. I'm going to show you what I see on my display. What I see is very simple here. This is my instructor here, this little window here. You see this here? And it says 20 here. 20 means that 20 people, 20 of you have been playing with your clicker. It's okay. Press. Go ahead. Press and you'll see the number go up. See? Each time somebody clicks, this number goes up. Okay. I can make this window a little bit bigger. And then I can press on this button and I can see the distribution of clicks. Why don't you all press 1 now? Please all press 1 now. Press 1 now. Very good. I love it when my audiences follow my instruction. My students are not that good. When I press this stop button here, it freezes the display. Now, if you press, try, you will see a circle with a line in it. Right? And now you can no longer change this. It's frozen. Okay. That's all I have as an instructor. It's very simple. Which is important because when you're teaching, you don't want to be fighting with technology. By the way, everything I'm going to show you today, we can do without technology. What I'm going to tell you today is about pedagogy, not technology. We could do this by having fingers on the chest. 1, 2, 3, 4, 5. But I could tell you all, at the count of 3, put your hand on your chest, indicating your choice. That's a very simple technology that works just as well. Okay. Look on the back side of the clicker. Turn it around for a moment. And you will see that there is this barcode. Each clicker has a unique serial number. Oh, thank you so much. Thank you. Each clicker has a unique serial number. And each time you press, it sends the button you press, but also the serial number. So you may think that you're sitting there anonymously. No. I know exactly. No, I'm just kidding. I don't know who you are. But if you want, with real students, you could actually track individual students' responses. Okay. So that's all about the technology. My talk really is going to be about education. How do we educate innovative minds? How do we get people to think? How do we get people to be creative, to be okay with risk? And before I answer that question, I want to do a little exercise. I would like you to take a little piece of paper to write on. And I'm going to ask you 2 questions. And you're going to write down the answer to that question. You will not need, you can be very honest, because you will not need to give me the answer. It will remain private. Okay, so here's the first question. Think of something you are good at. Something you know you do well. Something you are proud of. Something other people respect you for. You know, it could be public speaking. It could be teaching. It could be, baking cakes. It could be photography. Anything. Something that you know you're really good at. And ideally, I want you to choose something that has been important in your career. Something that has advanced your career. So I'm going to give you a minute to write that down. Okay, did you all write down something? Does anybody need more time? You're successful, so it shouldn't take much time. Does anybody want more time? Raise your hand if you want more time. Okay, so now you can hide what you've written down. You don't need to show it to anyone. Because I'm going to ask you now a second question. And the second question refers to what you answer to the first question. Here's the second question. How did you become good at whatever it is that you wrote down? Where did you learn that skill or that knowledge? What did you do to become good at whatever it is that you wrote down? This is a difficult question, because when we're good at something, we enjoy it. And when we enjoy it, it's not hard to learn. The learning takes place automatically. We own the learning. We take ownership of the learning. So think back about your past and write down in a few words how you became good at whatever the answer was that you gave to the first question. I have done this little exercise all over the world. I've done it in North America. I've done it in Europe. I've done it in Africa. I've done it in South America. I've done it in Australia. I've done it in many places in Asia. I've done it in China, in Japan, in Korea, in Malaysia, in Taiwan. Anyway, almost everywhere except here in Thailand. And there's something interesting about the answers to the second question. Because you get the same answers all over the world. Whether you ask the people in China or you ask the people in Brazil, you get the same answer. Maybe that's not that strange, because we're all human beings. Our brains are wired to learn in the same way, whether you're in Argentina or in South Korea. But as I said, I've never done it in Thailand. So maybe you are very special. I'm sure you like to think that you're very special. So let's see. When you collect the answers to the second question, they tend to fall in the following 4 categories or 5 categories. I became good at it by trial and error. By trying something and then making mistakes and then trying again. I became good at it by listening to lectures. Now, the word listening is not here on the screen. But as you well know, giving lectures is very different from listening to lectures. I mean, I often, if I want to learn something, I teach, because teaching is probably one of the best ways to learn something. So that's not what I mean by 2. By 2, I mean by listening to a lecture, just like you're doing now. 3, I became good at it by practicing. 4, I became good at it through apprenticeship, by working with somebody who is really, really good at it, and then looking over that person's shoulder, and then learning from that person. And then 5, you know, there's other things that people say, like friends and family, and so on. I would like you to choose whichever is closest of those 5 choices. Please press the button that is closest to what you wrote down on your little piece of paper. And then let's see if you, Thai people, are different from the rest of planet Earth. If you are, I'm going to publish an article about this. So I have 32 votes. So let me repeat. 1, trial and error. Trying it, making mistakes, learning from the mistakes. 2, listening to the lectures. 3, practicing. 4, apprenticeship. 5, anything else. 10 more seconds before we see whether or not you're different from everybody else. 5 more seconds. 2 more seconds. 1, and there we go. I know you're not different from anybody else. You're exactly like the rest of the world. Everywhere people say that they become good at it by practicing. Typically between 50% and 70% say practicing. But, you know, that's not why I did this little exercise. There's something else really interesting about this distribution. What is it? Look carefully. There's something really interesting about it. What is it? You can say it in Thai. They will translate it. No lectures. 0%. Zero. Usually there's one or two people, but here, zero chose lectures. Zero. Absolutely zero. And how do we teach? This is how we teach. I mean, look at this room here. This is how we teach. So, we see something strange right away. We learn by doing, but we teach by telling. So we see that there's a mismatch between our approaches to learning, our innate approaches to learning, and our standard approaches to teaching. So here's what I'm going to do. I'm going to talk a little bit more about education. What is education exactly? And after that, I'm going to talk about peer instruction. Peer instruction is a technique for teaching which I developed after discovering that my teaching wasn't good at all. When I started teaching at Harvard, I was never told how to teach. I simply taught the way my professors had taught me. I'd learned physics in a room like this, so I thought, this is how we learn, and this is how we teach. And when they asked me to teach at Harvard, I basically started to lecture. This is me, many, many, many years ago. Before computers, you can see I'm using an overhead projector. No computers yet. Okay, so it's a very old picture. So I started to lecture. And what happened was that the students told me that they liked my lectures. I was teaching pre-medical students. I was teaching physics to pre-medical students. These were not students who wanted to learn physics. Oh, no. They hated physics. But they had to take physics in order to go to medical school. Most of my colleagues didn't want to teach this course because pre-medical students are not very kind to physics professors. I didn't know that. Plus, I had no choice. So I basically taught it. And then very quickly, I got very nice ratings from the students at the end of the semester. And I started to think that I was a really, really, really good teacher. In fact, I thought I was the world's best physics teacher. But I wasn't, as I will tell you later. It was all an illusion. So once I discovered that I wasn't a good teacher, I changed my approach to teaching. That's what we'll talk about next. And last, I thought since we are in an academic environment, we are going to end with a test. Uh-oh, I'm sorry. I didn't tell you in advance, but we'll have a test. So you better pay attention because the test will come at the end. So let's start with part one and ask ourselves this question. What is it that happens in a lecture like this or like that one? What is it that happens there? I want you to describe to me with one or two words, and you can say it in Thai, somebody will translate it for me. In one or two words, I want you to say what is happening on the screen here behind me. And ideally, I would like to hear a verb. But there are two verbs I do not want to hear. Teaching and learning. So you'll have to use other verbs. So go ahead. I will... Sleeping? These are my students. He said sleeping. You know, now that you say sleeping, I can't resist quoting something that Albert Camus said a long time ago. Some people talk in their sleep.